Welcome to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.
Hello and welcome to Landwards, the podcast of the Institution of Agricultural Engineers. I'm your host, Andy Newbold, and I am joined today by Tim Chamen. Hello, Tim.
Hello, Andy.
Thank you very much for joining us today. Just by way of a little bit of background, Tim is an agricultural engineer of some repute who has pursued a passion his entire life regarding soil and cultivations and machinery, and more of that in due course. But as is often the way, Tim, let's start from the beginning. Tell us a little bit about your background.
Right. Well, I was born in Reading, and lived there happily in a rented house with my father and mother and family. My father died when I was 11, and that really did change things quite a lot. We had to move out of the house. I'd failed my 11 plus, so I was going to a secondary modern. Wasn't very happy there, and in fact, my mother arranged for me to go to a boarding school in Dorset, which I thoroughly enjoyed. It was a bit of an unusual place. It was a co-ed progressive, but it was fantastic. Very much based in the countryside.
And you know, obviously that was a big involuntary transition, for want of a better word, at the age of 12 or so. In turn, this leads on to other things. But why did you decide to become an agricultural engineer?
Good question. I don't really know quite when I made a conscious decision.
A drift into agricultural engineering.
I mean, I spent leaving school. I spent 2 years on farms, and I then took up some. Well, I almost became a professional student, spending 6 years at different colleges. I think it was when I left Usk, where I took a national certificate in agriculture, that I obviously had made the decision there, because I went on to take an OND in agricultural engineering. So something had prompted me at that point. It was sort of in my blood. My grandfather and my father were both engineers, albeit electrical engineers. And of farming in the family as well, of going back. It must have been in my blood, I suppose.
Yeah, no, that's good. You've kind of sort of glanced upon your studies. Do you want to just take us through a brief timeline of school onwards as to what you studied and where it led you?
Right. Yeah, I left school at 18. It was an anti-rat race school, actually. So they weren't pressurizing you to take exams and get O levels and A levels. But I left at 18, having actually got 7 O levels in dribs and drabs. I worked on farms for 2 years, sort of arable, dairy, sheep, beef. And then I left. I thought I need to have some training. I need to know more. So I went for a 1-year course at Usk, taking a national certificate in agriculture. And then I followed more the engineering route and went to Rycote, basically to get A-level grade sort of qualifications in the form of an OND in ag engineering. And then went on from there to do 3 years at CILSO, which was the National College of Agricultural Engineering at that time, and I got a first degree.
Okay. And from there, where did that lead?
Well, during that time, the college being at CILSO, just over the road was Rest Park and the National Institute of Agricultural Engineering, who were offering summer jobs. So I think for a couple of summers, I worked there on various different projects, one of which I remember was bale testing, and another one combine testing, in the days when manufacturers put their machines in for standard tests, so they could, demonstrate the capabilities of their machines. And that was, I suppose, it sparked my interest in agricultural engineering and machinery, and I from there really, and that was how I suppose I followed an engineering an engineering career, because when I left CILSO in 1971, the college, I actually just went over the road and joined the cultivations department at the National Institute. So and that was an interesting period in that the ministry were funding significant field trials in terms of machinery performance, cultivation, sowing, harvesting, etc. So we had 3 field sites at which we took the machinery and did all the operations needed to get crops in the ground and harvest them and measure yields and energy inputs. It was a pretty unique trial. In fact, I've not seen one since that's been done over the length of time and with the amount of detail that was pursued with that experiment. So, yeah.
And do you think that, given that that was sort of, 1971 or so, of the early 70s, do you think the results of that trial still stand up today in the contemporary world of regenerative agriculture, for the sake of argument?
I do, actually, very much so. And in fact, well, touch on it later, but I've written some book chapters recently, and I've quoted those results because they still stand. They were fundamental. So you're looking at the draft requirement of plows, draft requirement of different tine cultivators, disc cultivators, drills. It all still stands. Okay, you can.
They're fundamentals, aren't they?
They're fundamental, and that's why that experiment was so valuable. Really, and very few others have done that. And there was a lot of time and effort put into doing it, and a lot of measuring devices, etc., that were available at the time. So they were valuable trials.
And where did that lead to after that then?
Well, when that finished, and I suppose in parallel with that, we were also looking at how we could improve the efficiency of machines. And one project I spent quite a bit of time on was developing what we wanted to achieve was a low draft cultivator that did quite a rigorous job of cultivating the soil. So we looked into what we call a rotary digger, and this was draft neutral. So we did a lot of work on how the sort of diameter of the rotor, the number of blades on the rotor, the speed, the relationship between forward speed and rotor speed. And there was an optimum where you got a lot of thrust from the rotor. So we actually had deep working tines behind the rotor. So you were doing, working to about 20 centimeters deep with the tines and about 10 centimeters with the rotor. And actually that made a really good job. And it was taken up commercially by the Howard Rotavator Company.
Yeah.
Unfortunately, it was at a time when farmers were burning straw, and they'd gone from fairly deep cultivations to very shallow.
Min-till.
Min-till.
Yeah.
And so it actually came onto the market exactly the wrong time.
Mm.
I think if it had come on earlier or later, it actually would have been more of a commercial success. But it did. I still think it was doing a really good job. And in fact, I wouldn't have any hesitation in using it in certain circumstances now.
And presumably the idea was that the thrust of the rotary digger helped contribute to pulling the tines through.
Well, exactly. And in fact,
as well as obviously loosening that top half of the section.
Yeah, it was doing 2 jobs. And in fact, we could easily use it on a 2-wheel drive tractor. 100 horsepower tractor was quite capable of pulling a machine sort of 3 meters wide. And but I say in commercial terms, it didn't take off because of the climate.
Wasn't there a German machine? Was it called a Dutzy, which was a big rotary tiller which had tires behind it? Yeah,
we actually had that to assess at the institute. It wasn't quite the same thing, and it wasn't doing the sort of job that we wanted to achieve. But there was a Dutzy, as you say.
They seemed to be quite popular from memory in the 80s, as well as being massively energy intensive and very, very heavy and very, very slow.
Well, our machine, I think we claimed and we could show that it was about half the power requirement of a plough. Or half the energy needed. So, and of course, you could use a 2-wheel drive tractor.
And presumably the forward speed was reasonable as well.
Yes. Yeah. Yes.
And certainly, if you had a 3-meter working width, if you had a 100 horsepower tractor on a plough, that plough would probably be pulling 1.2 1.5 meters of width.
Yeah,
Something
yes,
like that.
yeah, yeah. So yeah, as I say, it worked out a good machine, but just came onto the market at the wrong time, really. But, yeah. So yeah, after that, and I did various other work, subsoilers and the power plow. Had quite a bit involved with that because I don't know if you remember. Um, yeah, what was the reason for that? Well, they had the power plow, but of course it wasn't because it was angled. Tractors were very unstable when they pull it. The tractor tended to
Yes,
go around
because
in
the tractor
circles.
tended to tip over because the tractor sat in a furrow and it was quite pronounced from memory.
Well, no, the power plow was a subsoiler that you worked on the top of the soil, and it was designed really to loosen grassland with very minimal disturbance at the surface. So you could go in with it, and it would just create a slot because it was angled. Basically, the principle was that the leg was at the angle of the natural angle of failure of soil, so it would pass
Yes.
through the crack created by the
Yeah.
time.
Yeah.
Um,
So it sort of
but
made its own low draft requirement.
yeah, but because it was angled, it had a terrific side force on the tractor, and the
Yes.
tractor went round in circles.
Torque,
So
torque steer in engine terms.
yeah, yes, yeah. So I was tasked with, well, how do you sort this out? And in fact, what it needed was like a landside, but at the depth, right down deep in the soil. And in
Yeah,
fact,
just
Howard,
just to give
give,
an opposite effect.
yeah, give them their due. Howard Rotor Company took over the idea of stabilization, which I'd actually tried on a single furrow, but because it was a single furrow, it wasn't consistently reliable because there would be times when it wouldn't work. But if you put it onto 3 tines, then every more often than not, one or other of the tines was giving you the stabilization you needed.
Yeah, it
So
shared the load.
it shared the load. So it didn't work well on a 1 tine, but it worked well with 3. But
Yeah.
the idea I came up with was like a small mole plow. So you like a mole plow foot, which did
Yeah.
stabilize it. But of course it was more expensive than having just a simple landside. Anyway, that was yeah, so that was work I did for the first 10 years, I suppose I was at the Institute. And then I get pushed on to, not pushed on to, but I was introduced to an experiment to look at soil compaction, and that's really where my involvement in controlled traffic started, because this was a trial on a very heavy clay soil, um, and just a few years into that, we had 3 basic treatments of compaction: traditional practice, low ground pressure, and zero. And the zero was made up with a system with a wide axle tractor. In fact, a County 1474, which I think we bought it as something like 9,000, and about 20 years later, it sold for 34,000. It was a very valuable tractor. That anyway, that's an aside. But yeah, and when we're a few years into that, it suddenly dawned on me that where we'd got no traffic, then the soil became what I can only describe as a pussycat. It traditionally, I experienced that field, and the soil was really intractable. You came up in big clods. You couldn't get the cultivator to go in. But when we took the traffic away, it just was very easy to work.
Yeah.
In fact, we could get a seed bed just with a Dutch harrow, nothing more. Dutch harrow, seed bed, and you could sow your crop. Whereas the wheeled plots, whether they were low ground pressure or conventional, they required several passes. Their big clods would come out, a massive difference. So that was sort of a eureka moment in a way, in that I realized, well, all these years we've been trying to improve the efficiency of cultivation machinery, and here was the answer: don't run on it. And
Yes.
suddenly the whole world changes, and you get something. It's going to vary between soils. Not all soils will be perhaps quite as good as the one we were on, but most soils will react positively to no compaction, in that they will maintain a good structure. They are relatively easy to work compared with when you run on them. And yeah, so that was really at at the core of my passion for, well, if we don't run on soils, we won't have the big problems that we've been experiencing with them. And being an engineering institute, we then went on to think, well, hang on, is the tractor that we've got the best way of actually achieving non-traffic soils? And I'd done a bit of searching around in history and came across Alexander Halkett's work in the 1850s, where he developed a 10-meter wide gantry on rails. And he gave a treatise to the Royal Society. And if you look at the text from some of that, he basically was describing precision farming as we know it today. Very
Yes.
precise operations, multi operations in one machine, whether it's weeding, whether it's watering, harvesting, all sorts of things at the same time. And so that's how we got on to a project that aimed to develop a gantry system and assess it in the field and look at the economics and does it work? What can it offer? So the next 10 years actually were taken up with developing the machine so they could do all operations that you might want to do on a farm, on an arable farm. So we can actually plow with it. And it's obviously not across the full 12 meters, which was the width of the machine. But we had two furrow plows, one left-handed and one right-handed. So you could either start in the middle and work from the middle of the machine and move them gradually out to the wheels. And the other way, next year, you'd do it the other way around. So you didn't create a big furrow in the middle or furrows at the side. So you alternated. And that worked very well. We could pull, with 100 horsepower, we could pull 4 furrows, whereas alongside, we had a 100 horsepower Massey tractor. It could only pull 3. So
Yes.
therein, immediately you see the big difference in soil conditions. And the other difference was that the soil that our plough turned over was almost immediately able to sow into. Needed very little additional cultivation. And in fact, eventually we actually shallow ploughed rather than deep ploughed, because we thought, well, we've got a good structure right through the plough depth. Why plough that deep? So we were ploughing primarily for weed control, and the shallow plough worked well on the gantry. And again, we'd have, if it had been taken on commercially, then you would have wanted two ploughs, one left and one right, but we didn't take it that far. But yeah, it took quite a lot of time to get the whole thing together to actually create a system that worked right the way through the whole production cycle. So that included harvesting, of course, which was quite a challenge, but we got it to work in the end. And having just got it to work, of course, sadly, the ministry pulled the plug on the project and said, well, we think it's too near market. Well,
and of course, that's the point of technology transfer, isn't it, Tim?
Yeah, yes.
The point is to prove some innovation and take it out for people to use.
Yes, exactly. And well, okay, David Dowler, who at the Dowler gantry, was out there, but his was only a system. He could cultivate and sow and spray and fertilize, but it wasn't a complete system. It was a very good machine, and in fact, we had one of his machines at the institute to do the spraying and fertilizing operations. It just made the whole job a lot easier. But yeah, and so the plug was pulled, but we did have some interesting times with the machine. You can imagine 100 horsepower, hydrostatic drive, quite a complicated thing. We had a lot of filtration in the system. Cooling we didn't have, but that didn't actually become necessary because we weren't ever working a whole day. We tended to work in short periods. But one day we were working on the plots with a 12-meter wide cultivator and measuring as well. We had a lot of instrumentation on board as well as telemetry to transmit the results to a stationary vehicle. But I was sat on the machine monitoring the instruments, and suddenly the engine stopped. I thought, why's that stopped? Anyway, the driver and I looked at the far end of the machine. We thought, wheel's in a bit of a funny position. Went to look at it, and in fact, this 80 millimeter shaft, which rotated the wheel, had just sheared off. And obviously, the hoses and everything, the hydraulics were still connected. But miraculously, at the end of the machine, we had a panic button, which you just shoved your hand against to shut the engine off. And the shock of the shaft breaking was enough to trigger the panic button. So the engine stopped, but only at the point at which the wheel had gone forward just far enough for the end of the gantry, rather than falling on the ground, just came to rest on the tire. So
a gentle halt.
a gentle halt, but it could have been catastrophic.
Yeah.
Because you imagine oil at a pressure of 420 bar flying all over the place from hoses, and it would have been horrendous, and the machine would have gone right onto the ground and broken. Whereas the only damage was actually the shaft. So we were pretty lucky. But, no, one thing I talked about a eureka moment earlier, but there was another eureka moment when we first got this machine to actually work in the field. So there was me, 12-meter wide cultivator, 100 horsepower engine, going across the field with this machine. And I looked at what was happening behind, and I thought, this is just magic. We've got a 12-meter wide bed here with no compromising wheels running over it. And I spent the previous 10 years thinking about the old drills. You used to stand on the back of the drill and check they're all working right. Well, where the wheels ran, it never worked properly. The seed wouldn't go in the ground, and there were always problems with the contrast between the wheeled area and the non-wheeled. Of course, you got none of that with the gantry. It was all, it just was, I just smiled to myself and I thought, gosh, this is exactly what we want. So that was another eureka moment, but sadly, it's not quite got to the stage where everybody's seen that, but hopefully in the very long term,
I think you've got a few $1 million. You can go and buy a setup now, can't you, from Nexat, which will do the job. But it's probably not necessarily that accessible to the majority of the UK's farmers, is it?
Not yet, no. And in fact, they've just opened sales in Brazil. So they're going at it. And I've got great admiration for those guys. I mean, the complexity, the development of that machine is just astounding what they've done. And
it's fascinating when you go and stand. You've seen one in the flesh.
I have,
I remember walking around it at Agritechnica 2 years ago, and just being awestruck with the physical size and the fact that effectively on the harvesting module there were 2 axial flow combine drums within it. The sheer size, the potential output. To say it's exciting, Tim, is an understatement.
Yeah, exactly. And the harvesting bit of it, that when I worked on a project with a Swedish guy, the harvesting bit was the most difficult to imagine how we were going to get the results. And we had some ideas, and based on stripping harvesting and bagging and vacuum and all sorts of stuff, whole crop harvesting, you name it, we went through it. But no, they've achieved it. And of course, they've got the output of their harvester is way surpasses anything that's on the market at the moment.
And that includes turning the crop through a 90-degree angle at the end of the header, splitting it in half and turning it left and right to put it through the combine drums.
Yeah, exactly. And the other advantage is that the light fraction chaff and straw is chopped and spread over a much narrower area, narrower width. So you haven't got this massive variation across a 12-meter header, for example, where you've got a heap of stuff right in the middle and very little towards the outside and prone to wind. So they've they really have knocked a lot of problems on the head and solved them, which is fantastic. And I had the privilege of talking to them for probably a couple of hours at Agritechnica. And yes, very knowledgeable guys. The father, Clemens, he'd spent a lot of time working on harvesters, hence his knowledge and ability to come up with this amazing idea of how it works. So yeah, I think I'm sure. I mean, there's 14 meters at the moment. They've talked about 20, but if you can do 14, you can do 6. And I think 6 would be perfect for the veg industry. I've worked
Well,
with
it's a sweet spot with a machine which is relatively inexpensive,
yes,
and
yes,
because of the value of the crop, the value of the crop would justify that A, the sacrifice of land, and B, the value of the machine, wouldn't it?
yeah, exactly. And it's 6 meter machine for potatoes is perfectly feasible. I've looked at it with a colleague, so another research colleague in Tasmania, and yeah, we think a 6 meter machine would be the perfect solution, initial solution anyway, for the veg industry, whose impact on soils is far greater than the arable industry. Um, potatoes is really potato harvesting is a disaster for soils. Really is. In fact, a
Yeah,
lot of it is a
absolutely.
disaster. Creating these deep beds, um, wheels well down towards the subsoil, doing all sorts of basically irreparable damage. Um, because it's so deep, you just can't afford to
And,
repair it.
and you look at some of the activities which we routinely do now. Harvesting maize is another one. You look at some of the crops in big
Yeah,
rotations, and they routinely, habitually require us to do things to the soil which we really shouldn't do, like drive on them when they're at field capacity with
yeah,
really heavy tractors, whether they've got tyres or tracks, is pretty much immaterial with the state the soil's in when you've got to go and harvest crop.
yeah, exactly. I did talk to the Maize Growers Association quite some time ago and said, well, look, you can do control traffic in maize. It's just a case of I want to do it and therefore I will do it. Like the farmers in Australia. Um, they said I want to do it. And that's the main thing to change what you're doing now to what you're going to do in the future is wanting to do it. Um,
Yes, it's
and
desire driven, isn't it?
it's desire driven. And unfortunately, I don't know anybody yet in maize who's adopted controlled traffic, but it can be done. There's no great complication, just a bit of thought, bit of lining up of machines, lining
Yeah.
up of planters, etc. No great shakes. It can be done.
And there's once the crop's in the ground, there's very little to do before harvest, in my
Yeah,
experience.
yes, yeah, that's right. And anyway, that can be done with machines that are working in the wheel tracks of the
Yeah,
the chemicals or yeah,
absolutely. And again,
yeah.
limiting that. I mean, given that we've neatly segued from your gantry, your early gantry work at Silso, at Rest Park rather, into controlled traffic farming. Maybe you want to have a bit of a chat about how that transition occurred in your career, Tim.
Yeah, right. Well, yes, actually, following the cessation of the gantry project, I got put onto things that were very much lab-based, measuring soils that other people's had experiments, basically. And when the chance of voluntary redundancy came up, I thought, well, actually, yeah, I'm not doing anything very interesting here. I'll take it. And after what I can say, I suppose, is a skirmish with ISO 14001, which I quite like because it you went into machinery manufacturers or any sort of operation that was building stuff, doing stuff, and looked at the way they were doing it and can suggest ideas. Well, actually, you could save a lot of money by doing this or not doing that or whatever. Anyway, unfortunately, it had got ISO 14001 consultants had got sort of tarred with the brush of ISO 9001, where I think a lot of people were ripped off and they were said, no, we'll do it ourselves, thank you. We'll learn how to. So that didn't last. And then I did some work for a Swedish guy, Ingemar Björnvall, because he wanted to develop a gantry and build a gantry. So quite a lot of time was spent with him. Very interesting times because he he was changing his mind quite a lot. But, he always took you to the best places and whatever. spent a lot of time in Mayfair, does his residence there. Also spent a little bit of time working in Sweden, had a desk there for a little while. Yeah, it was good fun. But he never quite had enough money to develop it. During that time, I thought, well, I'd like to push controlled traffic a bit more in this country and step in the Douglas Bomford Trust, who gave me some money to go out and talk to farmers about it. And I forget how many farms I went to or farmers groups. But one of the groups was a global ag managers from Unilever at, well, they've got a base in Bedfordshire at Colworth. And a few weeks after I'd given that talk, I was contacted. I can't remember the name, unfortunately, of somebody from Colworth, the UK Unilever Centre. And they said, well, we're interested in this. We'll prepare to offer you a field to set it up, see what it does. Well, yeah, that's great, but I haven't got any equipment to use in it. Anyway, I recently done some work for John Deere in the US, their Horizon 2020 group. And I knew from that they were interested in soil compaction and dealing with it and whatever. So I contacted the guy I'd worked for and I said, look, I've been offered this field by Unilever. I haven't got any machinery. Do you think John Deere UK might offer something? Next thing I knew, Jonathan Henry rings me up from John Deere UK. I think he was MD. And he said, what would you like? I thought, oh, wow. Yeah, I'll have a combine harvester, please, a tractor, a drill. And we thought, well, we can probably direct drill. Anyway, it turned out that their drill that they were currently offering on the UK market, they were taking off. So step in Ed Dale of Dale Drills, and he offered us a drill to use. And so we were in business. And we operated at Colworth, firstly on one field, and then they were enthused by the system. So they let us have 7 fields, which allowed us to get into a rotation. And we did have farmers groups come out there and look at what we were doing. And I could say almost universally, within 10 minutes of standing on the control traffic field, walking a few yards to a similar no-till system with conventional traffic, they were convinced. Yep, absolutely sold on it. Because you could just see the enormous difference in the soil condition between those two treatments. And we had a little group, a sort of a focus group, and we gradually increased membership and held workshops all over this country. We then expanded. We had a sort of a launch of a membership group at Agritechnica in 2007. I got a Danish colleague to join and a German colleague and a colleague from Slovakia. So we had a sort of a 4-way partnership in setting up workshops around Europe as well as in the UK. And yeah, as a result of that, I think we made a bit of an impact. I think there are now quite a few controlled traffic farmers in the UK and hopefully quite a few across Europe. And yeah, I know a year or two back, I gave a talk to a farmers group in Norway. I did it on Zoom or whatever. And they were very interested in control traffic for grass production. And there tend to be the small machinery, but it was just an interesting project to work on because machinery wise, I looked across the broad spectrum of machines that they were using, and it's surprising. You could just come up with little ideas about, well, I could modify that machine and actually that would work. You know, you just tip the bale somewhere else or do something.
Yeah.
And it's very, yeah, it's really satisfying to do that sort of work where you can find little things that are not expensive to change, but can revolutionize how you can work. So yeah, it was good fun. And
so while you were doing your CTF work and running your workshops and starting the group, what else did you do?
yeah, actually, I was trying don't know how what prompted me, but I thought I'd like to do a PhD. And Colworth, of course, the site where we got controlled traffic, enabled me to pursue study in an area of, what does controlled traffic deliver in terms of arable farming systems? So we had a site at Colworth already set up, available for us. We also were closely associated with the farm, growing onions and cereals and whatever. And we set up a site on that farm as well. And historically there'd also been some work at in Norfolk at name's gone. But anyway, the arable group there had done some work. So we had some results that we could use that were historical, and we then pursued that at those two other sites. And in 2011, I was granted a PhD, which was, I have to say, it was very satisfying. I'm not sure quite what it did for my career, other than if you were talking to people about doing a job for them, to actually have PhD after your name did give you some standing, and also not only that, but CEng. I think CEng is equally important to have behind your name if you are touting for work with somebody. They see a CEng after your name, they think, well, at least this person has studied and got some reputation in being able to solve engineering problems. So yeah, I found that well worthwhile and satisfying that you'd managed to achieve it while doing a few other things as well.
Yeah. So fast forward to 2023, Tim. Tell me what happened 2 years ago.
2 years ago.
In Hanover.
Yes. Yeah. Sorry.
I'll give you a clue.
I know. Sorry. Yes, I had a surprise email saying that I'd been awarded the Award of Merit for Innovation into Practice by the Eurag Eng, and would I be available to receive that award in Hanover just prior to Agritechnica? So I was absolutely delighted, got a bit sort of gobsmacked. And yes, that's what I did. I caught the train and made my way together with my wife, Chris. And we turned up in Hanover, and I was presented with this in the audience of several hundred, which was quite daunting, actually. I was far more nervous accepting that than I was going out and talking about CTF. It was totally different sort of situation, but no, it's a very nice thing to have, and it's actually sitting just behind me here in my office. The award, which is Man Tool Sky, I think it is called.
That's what it's called. Yes, it is.
Yeah. Yes. Yeah. And it did actually stand. The original stood at the top of the staircase at Rest Park for some years. It was in wood, and I've got a 3D printed copy of it, which is very nice to have. Yeah, and it was then while I was there receiving that award that I met up with Clemens and Felix Calverkamp of the Nexat. So gave me the chance to have a chat with them, which was great. Yeah.
And it must be a real sense of satisfaction or pride or warmth, or there's probably a series of words you could use, to be able to meet the team behind the Nexat and think about the building blocks you put in place to see where that has gone over the range of agricultural innovation of the last 3 decades or so since you started your work.
Yes, yeah, it was, and I've got a sneaking feeling that I don't know how Clemens came upon the idea of the wide span or gantry tractor, but one of our workshops was on the island of Samsø in Denmark, a grower there, and I was talking to him about gantries, and he obviously just really took that in, and he, together with Hans Henrik and the company Acerlift put in for a grant to build a machine. And sure enough, they built the Acerlift 9600. And it was basically you could carry out cultivations, onion lifting, and a range of tasks. But Clemens Calverkamp, I think, were working with Grimmer. He was working at Grimmer, and whether he came across the idea then, I don't know actually where he came across the idea, but it would be nice to think that it was triggered by that work in Denmark. But
I've actually Googled the Acer Lift 9600 now that we're talking.
right.
You know, as you say, it is a wide-span vehicle of some repute, isn't it?
It is quite a size, yes. And they were able to change the center section from an onion elevator to a full width cultivator. It took a couple of guys an hour to change the whole center section. Well, of course, Nexat now, by the clever design that they've got, the U shape in plan that they've got enables it to drive in to different units.
Yeah.
And of course, it's all done automatically, always done. Yeah, it's done without any human intervention other than on the control systems, remote control systems. So very clever. But, yeah, so things have happened gradually over time. And yes, it is with some satisfaction that I see that CTF is now recognized, although not widely enough. I still think that people don't really, I can sort of understand it, but they pay lip service to it. Well, no, they don't pay lip service to it. That's probably the problem. They don't seem to see it as a solution.
And I think economics tends to drive people down a horribly conventional route called bigger, harder, faster, better, more, doesn't it, Tim?
Yeah,
Rather than sort of a pause of reflection to say, we're stuck between the soil and the sky. We can't do a lot about what's happening in the sky, but we can do an awful lot about what we do with the soil.
yes, yeah, yeah, and I think, I mean, one thing that controlled traffic doesn't need, and that is serious thought. You've
Yeah,
got to actually think about what you're doing, because you don't get stuck into something that's going to constrain you for the future. So you've got to think about what widths you want to go into, how flexible that is, how it fits into your whole farming system, and then plan. I know I hosted a group of farmers from Australia in 2009. We spent some time in Netherlands. Where did we go? We went to Netherlands, Denmark, and here in the UK. And I took them around different farms, CTF and whatever. And the key thing about those guys, they were always talking about how can we do this better? And
yes,
it's a case of gradual improvement. You start at one place and then you gradually improve on it. And these guys were always talking about things they saw. How could we improve ours to mimic that or avoid that or whatever? And I think that's what controlled traffic farmers are all about. They're forever inquisitive, forever trying to improve things, and only that way really can you improve things. You've got to rethink about what you're doing. And in fact, in one of our newsletters, which I know you're about to publish, I look into looking at your soils. You can make assumptions about your soil that can be totally misguided, really.
yeah,
What you need to do, and in my case, I always say, test your soil using a fork, because as you push the fork into the soil, and in very dry conditions, you probably need a fork to get anything in. You actually learn something as you push the fork into the soil. You can feel different resistance to the fork as you go in. A spade tends to be too much of a blunt object. You can't get it in. You don't get it. It's just not the right tool to sample a soil. So put your fork in, you've immediately got a picture, well, actually, I've got a bit of a tight bit there or not, whatever. But have a look at it. And I was, intrigued to know some controlled traffic farmers have said, well, my soil's getting a bit tight and I felt I needed to loosen it. But did they actually look at it carefully? because when you look at it, it might be tight, but actually the structure is perfect. It's
Yeah.
just that it's stabilized and you've got loads of porosity.
And a clay soil will stabilize with a different tightness to a sand soil, won't it?
It will, yes. And that, but as part of my PhD, I did ask the question, will all soils respond positively to no traffic? And it was quite difficult to find soils that hadn't historically been trafficked or only been trafficked a long time ago.
Yeah.
But I went round sandy loams, clays, as many as I could find. And the universal answer was, well, they do all respond positively. They are always better structured, easier to cultivate if you need to cultivate them at all. The
Yeah.
other thing was, well, actually, other than weed control or things at the surface, or just getting that few centimeters depth of tilth to sow seeds into, they don't need any other cultivation. As long as you don't run on them, they perform perfectly well. And that's
Yeah.
right across a lot of different soils.
So we've sort of started this, and anyone who's listening to a few of these podcasts will know we start with a fairly vanilla set of questions. Now, the next one might seem a little sort of ironic, given the fact that you may be nearer the end of your career than the start at the tender age of 80 plus, Tim. But what's your day job like now?
Well, I have to say that a lot of domestic activities are involved. But no, I still try to keep my hand in by reading things when I can. I've actually just completed writing 2 book chapters, which are taking incredibly long time to actually appear in print. I think one of the first ones is probably 3.5 years ago now that I started writing that one. But anyway, that's very satisfying, and I I have actually grown to like writing. I don't know if you've had the experience, but there are some books you can read where a sentence jumps out at you, and I think, what fantastic prose! And you just reread the sentence again and again, and you think, how lovely is that? And
The,
yeah,
the challenge is it's not necessarily the facts, it's how you say it in
it,
a
it, it's
in
how
a
it,
sensible way.
yes, how those, what words are used to express the idea,
Yes,
or
that's exactly right.
yes, and so I quite enjoy trying to make what I write interesting, and yeah, I don't aspire to, I don't expect to achieve the sort of things that others have, but I do enjoy trying to make it so it's readable and interesting. Yeah. But
Yeah.
yeah, so I've done that, but yeah, I'm still championing CTF at every opportunity, probably to some of my colleagues' annoyance. But even they, people I've spoken to for years, I still feel that they actually are not championing the idea. They're still not convinced. It's like, yeah, it's like my neighbour here where we live. Um, Probably for the last couple of years, that I've said to him, Bob, I said, you've got a gas leak. You've got a gas leak here. And he's just not taken any notice. And the other day, I went round for something and I said to him again, you've got a gas leak. I don't think he really believed me. So I went, as somebody who's done a fair bit of plumbing, I went and got a paintbrush, a bit of fairy liquid or washing out liquid, and a bit of
Yeah,
water in
yeah,
the
yeah.
pot, and painted it on this pipe. And there, lo and behold, all these bubbles
Bubbles.
came
Yeah,
out.
yeah.
That
Practical
night,
demonstration.
demonstration. That night, he called the gas boys, and amazingly, they came. I think it was 10:30 at night. He rang them, and at 11:15, they were out, and fixed it. Fixed it. So yeah. So you can say things to some people for ages, and there's got to be something that makes it click. And sometimes you just don't have that key to make it click. So you've got to find that key. What actually does it for people to make them think, well, yeah, actually, maybe there is something in controlled traffic that I've not
Yeah.
properly thought about.
And
Anyway,
I also think we're a little bit more kinesthetic learners than we like to think. So we like to think we learn by reading things and, using
yeah,
the
yeah.
internet and sitting at desks. And
Mm.
sometimes you just need to go and get a bit of soil on your hands, dig a hole or do something and make some connections between your hands and your head.
Yeah, exactly. And I've learned a lot by digging my gardens. Um,
Yes.
it just triggers ideas and experiences, and yeah, get in there and, and dig it up, and and just get a bit of feedback from the soil. And
Yeah, no, I agree. And also going back to your point earlier about saying whether the soil feels tight or not, unless you know what your soil feels like anyway, you're not going to know what it feels like when it's any different.
no, true, true. You've got it. Yes, yeah. You need to. Well, I would say carry a fork around with you. A lot of people carry a spade, but I don't much like a spade. It's too blunt an object.
Yeah,
Carry a fork. It's a bit lighter. It's easier to get into the soil, and it tells you more. Um, and yeah, it does a better job.
yeah. There we
Mm.
go. That's the take home for the listeners of today. Forget the spade, and of course
Yeah,
it'll cause trouble with other eminent academics in this field. In this field, no pun intended. Forget the spade and get
yeah,
and get a fork. I quite agree.
yeah,
I'm kind of mindful, Tim, that we have been talking and recording for about an hour now. So I do
yeah.
wonder whether we should sort of get to a bit of a an and finally, because it's very clear that you're very excited and very passionate about the work you've done. Shall we just have a think about? There's two things really. We'll start with the big picture. What are the global things? What are the key issues you think are facing society and where ag engineering can fit in?
Oh, golly, yes. Well, yeah, in the terms of environmental issues, I think agri engineering has got a lot to offer in terms of, well, cutting down the amount of, in terms of soil engaging equipment, cutting down the amount of metal that is involved in those operations. I was looking at a drill the other year, a direct drill, I think it was, and the amount of metal in it to sow a seed 3 or 4 centimeters deep in the soil, it just seems mad. And I think there's a lot we can do with clever thoughts and obviously with soil conditions and making sure our soils are as healthy as they can be by not running on them. Then I think that feeds in to a whole big change in cultivation equipment,
Yeah,
such that you've got clever machines, much lighter machines, and less expensive machine. Well, they might be very clever, so they might not be that less expensive, but I think they've got to be a lot lighter
yeah.
than they are at the moment. Um, so I think agri engineers have got a lot to offer in terms of improving or reducing our inputs to crop production. I
Yeah.
mean, I think one thing I wanted to do, and I'm not sure I can achieve it, is to look at the carbon footprint of gantry tractor farming compared with conventional tractor farming. I'm sure if you take it right back to production of machines to satisfy the needs of those two different systems, then I think you will see a big difference
Yeah.
because yeah, and non-duplication of engine, cab, and all those different things that tool carriers have done for years. But yeah, I think there's a lot to go into there, and whether I'm able to achieve that or not, I'm not sure. It's quite
We'll
a big
keep on going. I mean, you make the point about being curious and keeping asking questions, Tim, as well.
yes, yeah, yes, absolutely key to everything. Um, when you go to cereals or machinery show or local show and you see things, think, why is that like that? Always ask the question why. You're probably a bit of a pain in the neck if you do, but sometimes you start out asking why, and somebody says, well, because of so and so. But then when you look at that so and so they just said, well, actually, why is that? And very
I mean,
often,
it
you
is the strongest question is why, but also you're trying to get to, again, no pun intended, you're trying to get to the root of the matter, aren't you?
you are, and very often, what you assume is the root is not the root at all. It's
No.
something quite different. And if you ask why often enough, uh, you can trace it back to something that actually you can change, that changes the whole system.
Yeah.
But you've got to go ask those questions and really think about the job. Um,
Mm.
it's yeah, it's very satisfying when you can do that. And actually, with ISO 14001, which I mentioned earlier, that was part of that, was asking the questions. Why are you doing
Yeah.
like that?
Examining
And
it, examining the
examining it.
process and
Yes, yeah,
understanding why that process was required.
yeah.
I'm going to ask you, as your final point, Tim, what advice would you offer to anyone considering heading into agricultural engineering as a career?
I I just say go for it. The world's your oyster. Um, Engineers have achieved incredible things worldwide. They've improved conditions for millions of people, and yeah, there are just so many positive things you can do. And a career in Ag Eng is not is a career in all sorts of different things, from all sorts of different technologies. A lot of them right at the cutting edge. Um, yeah, I would have no hesitation of doing that. And um, the I Agree has been central in my career in giving me a platform to speak as a young engineer in their conference in 1981, and that sort of prompted me to volunteer for the membership committee sometime
Yeah.
later and chairman of the local branch. It's given me a lot of payback in getting to know people and having the opportunity to
Yeah.
see things and always ask the question. Um, wherever you go or visit or whatever, just get to the bottom of what's the engineering aspect of the whole thing. So it's
Yeah. Never stop
very special.
asking. Never stop
Never stop
inquiring.
asking.
Do you know?
No,
I think
exactly.
that's a really good note to end on, Tim. So,
Yeah.
I think at this point, I'm just going to say again, thank you very much for your time and your effort and your input, Tim. It's been fascinating. It's a throwaway comment of saying we could talk for hours, but I feel there's a lot of common ground you and I have worked on together.
Yeah.
Behind a bit of this, and I find it fascinating just finding out more about yourself and what you've done. So, thank you on behalf of the listeners, and thank you on behalf of me for your time and effort today. Tim. Thank you very much.
Okay, Andy, and thank you. I've enjoyed it. Yes, thank you.
No, you're very welcome. Thank you, Tim.
For more information, visit www.iagree.org. You have been listening to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.